Hello, friends. Hello, guys. Nice to have you again, being part of my class. Thanks, thanks, thanks. So now we're going to focus on octinary number system. Remember, for different series or in different series, you'll be considering the binary number system, addition in binary number system, multiplication in binary number system, as well as subtraction in binary number system. So now we're going to focus more on the octinary number system. We're going to do addition and subtraction in octinary number system. Thereafter, we'll proceed, maybe next video, we'll proceed over to addition and subtraction in hexadecimal, which is a little bit different and trickish. We are going to sum up everything on number base before we think of going into some other interesting topic in mathematics. So for now, let's focus on octinary number system. Remember that octinary number system, also known as base 8, it's a system of numbers starting from 0 down to 7. So the system of numbers making up octinary number system or base 8 number system as 0, 1, 2, 3, 4, 5, 6, 7. Without 8 being inclusive, all the digits are already 8. From 0 down to 7. There are 8 in numbers. So now let's go into addition in octinary number system. Addition in octinary or octa number system or addition in octinary numeral system. So we're going to take example 1. The question is saying evaluate example 1. Evaluate the following expression or evaluate the following. Simple as that. You can simply say evaluate the following. You can simply say evaluate the following. End it there. So the question is, this should add 374 plus 2468. No, not 8. 8 is the base they're dealing with. And here, right here, 8 is the base. So the question is add 374 base 8 plus 246 base 8. Is it really different from binary? Different, but the same system or the same methodology can be applicable to have our answers. So what am I talking about? The solution will be this. Just pay close attention. It's not difficult. It's very easy. Just tell yourself you can do it. So what I was saying, going to do proper arrangement like you have in base 10. Then you're going to have 6, 4, and 2. All in base 8. What do we do? This is the more reason during the course of dealing with binary number system, I said there's no point cramming. Apply the same principle I use in dealing with binary number system instead of cramming. This is where the method I use over there is going to be more relevant to you, that you don't need to cram. So what happens? 4 plus 6, like you have in base 10, it is what? It is 10. Do we bring down a 10 here or write 0 down? No. Entirely a different ball game because we are not dealing with base 10. So now when we add, step 1, add this and this, you have 10. Now you divide by the base. You're dealing with base 8, divide by the base. This is where this system becomes relevant to you. So 10 divided by 8 is going to give you 1 remainder 2. How many times will 8 go into 10? It's 1. The remainder is going to be 2. So you write down the 2. Remember I said in number base, Remainder are very, very essential. You write down the 2, carry 1 over to the next line. So now, 7 plus 4 gives you 11. 11 plus the 1 gives you 12. The 12 is already bigger than 8. Like 10 was bigger than base 8. We need to divide. So we now convert it to base 8 by saying 12 divided by 8. Once again, 7 plus 4 gives you 11. 11 plus 1 gives you 12. So 12 divided by the base, which is A, gives you 1 remainder 4. You write down the 4, carry this 1 over to the next line. Simple as ABC. It's not difficult. So now we say 3 plus 2 gives you 6. Now 3 plus 2 gives you 5. 3 plus 2 gives you 5. Then 5 plus the 1 gives you 6. Of which, now ask yourself, is the 6 up to the base? No. See, the 6 is not up to base 8. You can as well just write it down. But if you still choose to apply the principle, then you simply say 6 divided by 8. You and I know quite well that 8 cannot divide 6. Or 8 cannot go into 6 instead. Therefore, it's going to be 0, remainder 6. 6 here. So the next thing you need to store in your brain is this. When you add, after addition, if the value you obtain or the answer you get is not up to the base you're dealing with, you quickly write it down like that without dividing. But even if you choose to apply the principle of dividing, you still have the same answer. There's nothing wrong with that. So quickly, before the video comes to an end, we're going to take another example, still on addition in octinary number system. Addition in octinary number system. Addition in octinary number system. Instead of taking another examples on addition in octinary number system, let's quickly do subtraction in octinary. Subtraction in octinary number system, because the same principle is going to be applicable. Taking another example. So subtraction in octinary number system, all we do is to say evaluate the following. Evaluate, what are we evaluating? We are evaluating this value, which is 475 base 8 minus 326 G. 326, this is 8. That was a typing error. So the question says, subtract 475 base 8 minus 326 base 8. Solution. Right, 4, 7, 5. This is the manual hand. The mathematics will call this the manual hand. I will call the next one, subtracting, the structural hand, which is 6, 2, 3, base 8, base 8. Let's do a normal subtraction. When we are done subtracting, if the value we get or the answer we get is up to base 8, then we divide. If it's not up to, we can choose not to divide. The answer remains the same. So let's do it. 5 minus 6, or 6 away from 5. Can 6 be taken away from 5? No. 6 cannot be taken away from 5. What do we do? Don't forget the principle. You have to borrow from the next line. We're going to borrow one from here. When we borrow one from here, here remains 6. But remember, in number base, remember in number base. You have to borrow, and when you borrow, the one you're borrowing become the base. Now, I had just borrowed one from here, making this 7 to be 6. The one comes here, but that one will become the base, become a base. So the one I'm borrowing becomes 8. So now 8 plus 5, 5 plus the 8, remember it was 1 I borrowed that became 8, which is the base, gives you 13. Now 13 minus 6. 13 minus 6 will give you 7. 13 minus 6 will give you 7. 13 minus the 6 will give you 7. So if it gives you 7, you divide the 7 by the base, gives you 0 remainder 7. Remember, most of the time, there is no point. There is no point dividing again, since this answer or the value you get is not up to the base. So all you quickly have to do is just write down the 7 without dividing. But if you still choose to divide, you haven't gone wrong. You're still on the right track. The answer will be 7. So next, let's say we are left with 6 here. So 6 minus 2. 6 minus 2 will give you 4. The 4 there is on up to 8. Quickly write the 4 down. Even if you divide by the 8, you say 0 remainder 4. You still have 4. How about this? 4 minus 3. 4 minus 3 gives you 1. 1 is not up to 8. So quickly write down the 1. Is 8. As simple as ABC. As simple as ABC. Thanks for being part of the class. I do appreciate. See you over in next class talking about hexadecimal number. How do you subtract? How do you add in hexadecimal? Thank you. Bye-bye.